I've started playing around with capacitive touch sensors and microcontrollers, and they're really easy. All I've done is I've taken a piece of aluminum foil, cut it on a diagonal, and simply put some clear packing tape over top of it, onto a thin piece of cardboard. Tape that to my desk so when I press on it doesn't move. On the left, the stack of LEDs here will indicate the sensed position, this being leftmost, this being rightmost. And up here, these two LEDs, this one will indicate that I'm on the left half of the pad, this one on the right half of the pad. On the right side here, there's a overly complex motor control circuit. It's using a FET and a totem pole configuration set of transistors. I plan to drive a much larger motor in the future. This is just a little test motor. I have a 5-volt power supply, and this is a PIC 18F4550. And as you can see, as I touch the pad, the LEDs light up, and as I move my finger to the right, they progressively light more and more. And you can hear the motor revving. You also notice when I take my finger off, the motor stays where I set it, and the pad knows when I'm touching it and when I'm not. That is my little variable touchpad experiment. The code for this is incredibly simple. It's just reading the ADC input values. I'm not actually adding any additional stimulant to this circuit other than I'm just reading the values. The code to wait, basically I'm getting the ADC value from the left pad and the right pad, and I'm taking a proportional comparison, so I'm saying, 60% right, 30%, 40% left. And if you're to build one of these, I would advise having the left, cutting the diagonal like this, so that if you notice, as I move my finger up and down here, it also acts as the same speed control, but in the opposite orientation than one would expect. So I have my diagonal cut in this orientation. I'd suggest cutting that orientation. And there you have it, an incredibly simple gradient capacitive touch for a microcontroller.